Oh, this one's better. Okay, thank you. I don't think that I need it, but anyway.
Well, he's making video.
Yeah.
Okay.
Yeah, you should use.
Okay, you try.
Yeah.
Don't be rude.
No, don't be rude. Not rude. That's not good. Be fan. Anyway, boa noite, pessoal. Primeiramente, muito obrigado por vocês estarem aqui. Eu sei que é difícil, né? Véspera de greve em São Paulo. Lançamento do Vingadores, né? Então, mesmo apesar de tudo, vocês estão aqui. Em nome do seu Java, nós agradecemos a Oracle por ceder o espaço. E hoje vamos começar com uma palestra internacional, né? Quem aqui já ouviu falar do JSF? Quem aqui usa JSF? Opa. Oh. Quem aqui gosta de JSF? Não, pode mentir, cara. Então, assim, vou falar aqui com o Ed Burns. Ele é o pai da criança. Então, assim, se você não gosta do JSF, é um bom cara para poder reclamar sobre o assunto.
It's more than JSF to life. That's right. I'm ready to talk to you for sure. I'd like to know.
Então, assim, ele também é um cara de comunidade, ele também é músico, ele toca piano, toca trompete.
At Java 1, we have a lot of fun. Oracle Code 1 now.
Yeah.
Too much fun at Java 1. That was the song from the Null Pointers.
Yeah, exactly.
Cesar wrote the song.
E sem mais, vou deixar aí a palavra para o Ed. Muito obrigado, Ed.
Okay, thank you. All right, so I'm going to talk to you tonight about Oracle Coherence for Kubernetes. Now, this is going to feel a little bit like a product pitch. I'll try to make it as developer-friendly as possible. But I will start out with something extra, which is a little diversion about JDK 12, which is totally community Java related. So let me open up that slide deck. Here we go. All right, these slides were presented at JavaLand, which I'm showing the shirt here. If you ever get a chance to go to JavaLand in Germany, in the city of Brühl, it's a very good community-focused conference. Now, one of the things about jugs that I love is they are all over the world. So you have a beautiful Java community here in Brazil, and also in Germany, there's a vibrant Java community. In fact, this shirt is celebrating 10 years of the iJug, which is kind of like what you guys have in Brazil. It's a group of jugs, and they have a big annual meeting every year, and there's probably like 30 or so different jugs all over Germany. So it's a very active community. And so what we did with JDK 11 was lots of community contributions that came into the core Java. We had all those JIRA issues were marked as fixed, and over 500 of them were contributed by individuals and developers working for other organizations not inside of Oracle. So one of the things I like to say about JSF is if you know, regardless of what you think about the software itself, JSF was the first part of any internal Java thing to be open sourced. I was very happy way back in 2004 when JSF was beginning. We made the decision to do the reference implementation out in the open. And this was when the only way to do that, this was before GitHub was invented. This was when SourceForge was still a thing. And we had java.net, which was a site that Sun at the time invested IT resources in actually building and standing up a collaboration site. So when you think about it, Sun and java.net were kind of doing something like GitHub many years before GitHub started. And in fact, it was kind of interesting because they had a choice. When you created a java.net project, you could choose which version system you wanted. And one of the choices actually was Git. So it was a distributed way, to do Git even way back then. Although for JSF, we used Subversion. So it was okay at the time, but I like Git better. GitHub has definitely made the world more open, I would say. So if you go to this blog post here, it will show a little bit more detailed of the contributions, you can see we have, actually, I'll use the mic as well because I might move around. I just don't want to get feedback. Is this one on? Check, check. Okay. So this little graph does show Oracle puts the most money in because that's engineer salaries that are being spent to work on core JDK issues. But we had quite a few from SAP, quite a few from Red Hat, some from Google. So this is a fun little graph. And even other names like Alibaba, Qualcomm, you can actually search through the Mercurial tree and find some very interesting companies there. I'll do this. Okay. So one of the things that was a bit controversial was the introduction of this Java long-term support contract thing. And my personal opinion in this is that it's perfectly great and fine as long as, and this is a big if, but thankfully it's very easy to say yes, we have OpenJDK. And everything that we're doing with OpenJDK is free and gratis and just like what you'd normally expect Java to be. But if you're an enterprise customer, it makes sense that you are able to buy support, and it's priced very well. So when I've been talking to customers all week, they look at this and they're like, well, of course, this is normal, what you'd expect. Now, JDK 12 is the first version, the first release after the LTS release. And we really started our ramp down on it just in December. And we released it on March 19th, actually, at JavaLand. These slides I presented there. Well, actually, my colleague Dalibor Topic presented during my session. What else do we want to say about this? And this is kind of more forward-looking, but it's out now, so it's actually in the past. Here's the fun slide. And you might look at this and say, what? There's only this small number of new features? And the answer is yes, and I'm happy about that. And here's why. Now that we move to this fast release train model, we can put releases out more frequently and more repeatably and more reliably with a smaller number of features per release. So, I think that's much better than this really long blockbuster thing that companies would build their product release cycles around going to Java 1. All of us inside Oracle and prior to that at Sun would just like save up work and effort for the Java 1 release, and it just got to be hard to maintain. So this new release model will give us much more things more frequently. Smaller number of features, but more frequently, and actually that ends up to more features over the time, right? So a couple of them that I'll talk about here. The first one, actually the first and the last one are relevant to my talk tonight about coherence. The low pause time garbage collector is important because what I'm talking to you about is Oracle coherence, and it's an in-memory data grid. It turns a bunch of JVMs into an enterprise hash map with full fault tolerance and reliability and massive scalability. But this being Java, and this being a large memory consumption enterprise using enterprise grid, data grid, hash map, garbage collector pauses are troublesome. So this Shenandoah garbage collector is a very promising thing to try, especially for memory-intensive applications like coherence. And another memory-related one is this JEP. These are JEP numbers, by the way. If you just Google search for JEP and this number, any of these numbers, you'll be able to find it. This one is nice because prior to this, when the JVM was granted memory, it would not return it to the OS until ever the application terminated. With this JEP, promptly return unused committed memory from the G1 garbage collector. So that's just it's more important in a cloud context, right? Especially when you have very, very long running processes, as you do with coherence. The other one that's fun to talk about is the switch expressions. And this is an example of what's called a preview feature. So in order to actually turn this on, you have to give some additional command line flags to either the Java interpreter or to the Java C compiler. And when you turn it on, what you get is the ability to use switch as an expression rather than just as a statement. So it yields a value. And even more valuable than that is the notion that there is no fall through. If you're familiar with the Swift programming language from iOS, from Apple, there's no fall through in that. And I think it's actually a much better way to use switch because you can basically have lambdas inside of each of the cases, and there's no way to fall through. So you have to, the compiler or the runtime ensures that every possible case that can happen is addressed, or it won't, you'll get a syntax error. So you can download this now, it's available, JDK. If you want this, enterprise Oracle version, go to java.oracle.com. And if you want the open JDK, you can go to jdk.java.net. Now, I'm excited. I've been doing Java for a really long time. I started at Sun in 1997. And there's so many great things happening now. We've got the Graal VM. We have this sort of bloom of other companies doing different versions of their own JDKs. Now we've got Corretto from Amazon and Adopt Open JDK. So it's a very exciting time in the Java space, like it hasn't been recently. Now I'm going to go into the coherence part of the presentation. But before I do, I wanted to just ask if anyone had any questions here. We also are going to have a Q&A at the end with myself and Elder and Ottavio and special guest Bruno Souza, who should be here shortly. Yes?
Someone asked me in the chat if there's some content where we can read about it.
You mean like posting the slides?
Or
Okay, the question was online?
Yeah.
Oh, cool.
Yes.
So we have some online questions. I'll put this up on my slide share. So if you just go to Ed Burns' slide share, I'll put it up there. Okay. All right. Well, let's continue then.
Se tiver alguma pergunta, podem fazer em português, eu traduzo. Tá? Beleza. Okay, Ed, you can go ahead.
Okay. This is my stock bio speaker, slide. And the thing I want to point out here, though, is I've been very blessed with being in the industry for a long time and had a chance to start at the outside, at the very beginning, with this. I worked on this as a student programmer, just one little kid who did some stuff on the side. I didn't do any of the heavy work, but it did give me a chance to see what it was like to have a platform from the very beginning and then have it take off. And then moving over to Servlet and JSF, it gave me a perspective on the server side as well. So I have an understanding of how it fits together that comes from just being in it for a long time. Now this is an Oracle product, and I'm going to be talking about new features that are coming. So I'm going to put this safe harbor statement up. And so things are subject to change. This slide is more useful when you're presenting at a more business climate. So I'll go past it really quickly, but some domains place a lot of stock in analyst opinions. So we have some good analyst opinions backing up this product I'm talking about. I believe it's a good product too. So the analysts say we have a good, strong current offering. We have a good, strong roadmap for the future. And we're very good in the market presence for in-memory data grids. So I'll talk a little bit about the competitive landscape as I go through the presentation. But the first question a lot of people have is, what about Redis? And I'll get to that. These are some common use cases that people use coherence for. So the first one I'd like to talk about is the web scale use case. That's what we call the web scale. And coherence at its heart is much more than an enterprise hash map. It's actually a compute engine that turns a collection of JVMs into a data grid, where you can do server-side processing, querying, aggregation, and you can do it in a way that's very feature-rich and takes advantage of a lot of the features that Java already has, like lambdas and streams. I'll talk more about that. But this web scale use case lets you offload all this data processing stuff from your application tier to the data grid. So if you were doing queries and aggregations in the client side, not when I say client, not the browser, but like the thing that is on the other side of the browser, just not in the back end, that's the word I'm trying to say. If you're doing queries and aggregations in the middle tier, you can offload that workload to the coherence data grid, and it's more performant because your application can keep doing application stuff. The fast data platform use case is when you're taking a stream or multiple streams of data, ingesting them into coherence, and then you're doing some correlation or aggregation, again, that data processing stuff, and then sending that on to some other data feeds here, whether a fast one, it does further processing, or a big data feed for doing huge number crunching analytics, or high volume data feed. The third use case is the generic caching use case, and it's still super useful and very powerful, even though it doesn't really take advantage of the compute capabilities of coherence. But we do have back-end synchronization technology for anything you could possibly need. ATG, Siebel, PeopleSoft, SAP, of course, Oracle. So I'll talk about that when we get to a little slide about our product called Hot Cache, or coherence version feature that has Hot Cache. So when you're using the coherence data structures at the beginning, when it comes time to instantiate the cache instance, basically get a handle to the thing that lets you access the data in the cache. You have to make a choice up front whether you're going to use a distributed cache, a partition cache, or a replicated cache. So the replicated cache is something that everything you put in, it's automatically replicated right away to all of the other nodes in the cluster. Now it's using this proprietary high-performance protocol that we call TCMP, Tangesol Cluster Management Protocol, and it's been optimized and designed over the years to allow very quick, it uses multicast for detecting cluster membership, but if you don't have multicast in your network environment, you can configure it to use TCP or UDP, so it's whatever you need, it can run over that transport. And so that's how the synchronization happens. Heartbeats and cluster health, those kinds of quorum decisions all happen over the TCMP. So with the replicated cache, anything you put in is automatically replicated to every other node. It's not something that scales for writes, but it does give great read performance. The other approach is to use the partition cache, which is optimized to scale for writes, and it does the propagation in a more lazy fashion. Okay, so this is kind of a very high-level box diagram, just showing kind of the features that we have in the product. You can do MapReduce style aggregation using the Java 8 Lambda and Streams APIs. It's fully integrated into Oracle WebLogic. So if you have a WebLogic on your site, you're able to take advantage of coherence pretty much right away. So this is that back-end synchronization I was talking about. Oracle has a product called Golden Gate, which is a low-level synchronization engine for Oracle database and other kinds of enterprise technologies, such as coherence. So with this technique, you're able to have your coherence data grid application, which is really just getting all of its stuff from the database. And with this approach, then you could have a legacy application that's using plain old JDBC to access the database. And what we do is we have this Oracle Golden Gate, which is an enterprise product that does the synchronization for us in a very high performance, low latency way. And then we have this hot cache feature that synchronizes the data. So with this approach, it really does solve the stale cache problem when your external apps write to the DB. This is our product history. The thing I'll talk about here is this current release we're working on right now, 12.2.1.4. And the two big features I'm going to talk about are the Kubernetes operator, which is how you run coherence on Kubernetes, and management over rest, which is how you can operate coherence, whether inside of Docker and Kubernetes or not. It's still able to be administered via REST. Prior to this feature, the only way you could administer a running instance of the cluster was using JMX. Anyone using JMX out there? Or any other? It's a very old but very useful Java management technology. Okay. I'll skip that one in the interest of time. It has a feature called federated caching. Well, federated caching, you can have a coherence cluster that is replicated across multiple data centers. So disaster recovery is automatically handled for you. And you can choose different styles of distributing the replication or the multi-data center deployment. So active passive is a kind of a lazy style where it happens again in the background. It's kind of similar to distributed and persistent and replicated cache. Active is where it's, everything is happening in both places at the same time. And when you're doing active persistence, you sometimes run into conflict resolution, and you have to provide your own thing to resolve the conflicts in that case. So these are just called different topologies for how you're going to do the multi-data center replication. Okay, and please excuse me, I'm just going to skip through to the slides that I think are more interesting for the Jug audience. This one is definitely. So leveraging Java SE8 features. Coherence is a server-side data grid technology. So anytime you're having server-side programming objects, those are jar files, right? And if you want to make a change in that code, you have to figure out some way to deploy the jar file some way, right? Well, that can be a pain. And one way that we've decided to get past this is to use what I like to call frictionless APIs. And that is, if you can take advantage of an API that already exists in the platform and just provide it with new power underneath, then you're able to just introduce it to developers without introducing any new APIs. So we did this with Lambda and streams. So you're able to do your querying and aggregation, writing regular Java 8 Lambda expressions, which are serialized using either POF, which stands for Portable Object Format, or regular Java serialization, and sent over the wire and execute on the server side. And then the stream processing also happens with that as well. And this is also a fun feature because another frictionless thing is you can do asynchronous with completable future. So completable future is a JDK 8 class. Is anyone using completable future in programming? Okay. Then you're able to do distributed Lambda-based data processing in an asynchronous fashion already with Coherence without having to learn anything new. I think that's one of the main strengths of Coherence is you already know how to use it, because it's basically just a hash map on extra vitamins. Another style of asynchronous is RX. So is anyone familiar with RX Java or RX JS? The reactive extensions for whatever language you want. They have them for JS and Go and whatever, tons of them. Well, we have an open source project that brings reactive programming to Coherence. It's called Coherence RX. And I'll have an example of that later. This one is kind of, I'll just be real quick about it. Even though I did say everything is available with management over REST, and that's definitely true, the way we implemented it was by building on top of the existing JMX structure. So you're talking REST, and then that quickly goes through to the JMX layer. So we just basically provided a built-in mapping for the REST API. So that's a nice choice here because we have a new feature where you can have the management node be replicated. And so if one cluster member is selected as the management node, and then if that management node dies, another member can be elected as the new management node. So it gives you another layer of fault tolerance. Anyone using Docker out there nowadays? Okay. So we have official Docker images in the store for WebLogic and Coherence. And these are the Docker images that comprise the operator for Kubernetes. Let's talk here. For the Jug meeting, I think it's important to point out that even though Coherence is an Oracle product, there is free developer licenses for it on OTN. So if you want to play around with it, or maybe, here's the thing. A lot of what we do in the Jug is learn new things that can help us to stay relevant in the workplace, right? So enterprise technologies like Coherence, which are popular in banks, and Just earlier this week, I can't give out customer names, but one of the big clothing retailers, they're considering using it, and so in Brazil. So my point is, it's worth learning it, even though it's not a completely free open source technology, because it does give you some traction into the enterprise. Plus, if you find a job that is already using it and you have some skill because you downloaded the OTN-based license and learned how to do it, that's a pretty good leg up on other people. This is what the Coherence RX looks like. In the RX Java, you have observable, so everything comes back as an observable. And all you really need to do is take your regular cache, wrap it in an RX, and then you get back observables. So when you get an observable, it returns right away. It doesn't block. So here we're just doing a put. We don't care about the result. We're doing a get. Of course, we do care about the result. So what we're doing is return the observable, subscribe to it, and pass this lambda, which will execute when the result comes back. So it's a way to do it without blocking, and also without having to use completable future. So if you have two styles, you can use completable future, or you can use RX. The REST management API is very important because it helps you get an on-ramp to the cloud. Most cloud management technologies are using REST. Not very many of them are using JMX. So that's why it's important to have a REST-based API. In fact, even Kubernetes itself is using a REST API between its client and the API server. So this is what it looks like. You can run on any garden variety Kubernetes. You can run the Coherence operator, whether you're running it in your own data center or you're using a managed Kubernetes, as I've got here. And this approach also plays very well with Oracle FN. Have we had anyone here at the Jug talk about the FN project? Oracle Serverless? You did?
Yeah.
Okay, great. So when you take a stateful data grid like Coherence and you combine it with a serverless function as a service product like FN, you really can make a lot of progress because everything has state. Even the most stateless function as a service-based application, you have to have some way to mutate something. I mean, if you can not return any values or anything, it's like, where can you get work done? So that's why I think the combination of Coherence plus function as a service is a pretty rich area for exploration. So I'm not just talking about, we have plenty of industry customers, big oil, pharmaceutical, automotive, lots of customers are using it. But also all of these existing Oracle products are also using it as part of their implementation strategy. So I know this because we get bugs and we have to fix them. We also have support for JavaScript, Coherence.js. So it's an additional client that lets you access the Coherence straight from a Node application, for example. All right, we're going to finish up the talk with Coherence Kubernetes operator. The idea is give you a way to run Oracle Coherence where you want to run it, which is these days the cloud. If you're not using Kubernetes already, you probably will be very soon. Is anyone using it already, Kubernetes? Have people starting to hear it out there in the world? Okay, because it's definitely coming. I heard a very funny joke that was one of these jokes that I heard that sort of crystallized a notion that I'd had in my mind a long time, but it put it into one tweet, which was Kubernetes is just WebSphere for millennials. I don't know if that covers over to Portuguese, but the millennials are basically the younger generation that's entering the workforce now. And those of us that are older entered the workforce and we started using app servers. And now the younger kids are entering the workforce and they're using Kubernetes natively. So they really are doing the same kinds of things, which brings me to a little treat I have here. I did this book, Secrets of the Rockstar Programmers, which put me in touch with lots of programmers. I interviewed them and put their interviews in a book. And I've kept doing the interviews, even though I haven't put out another book yet. So I have got a chance to talk to Brennan Burns, no relation to me, who is one of the co-authors of Kubernetes, about this observation of the app server being similar to Kubernetes in spirit. So let's see what Brendan had to say about that matter.
In many cases, the things that you learn there still apply, right? You're still writing multi-threaded programs. I think that the biggest challenge is wrapping your head around how do you debug and deploy when there's lots of replicas of the same thing. You're going to have to start learning some tools that do things like aggregate logs, right? It's no longer okay to just log into a machine and dump its logs. Now you need to have a tool that aggregates all of the logs across a bunch of different servers into one. And then because of the volume, do querying. So your problem has become one of more of a data scientist than just a person who's a developer reading log lines.
So that's why the operator is such a good feature, because it has built-in support for Elasticsearch, Fluentd, and Kibana. So what we do is all of the nodes in the cluster are running Fluentd inside, and we send all of the coherence logs through that, which then we pipe it into Elasticsearch and then expose it in Kibana. And this stack, either ELK, Elasticsearch, Logstash, and Kibana, or Elasticsearch, Fluentd, Kibana, EFK, is a very popular thing in cloud development areas. Is anyone using Kibana at all so far? Okay, is it okay? Do you like it for doing logs? Yeah? Okay. Well, we've decided that, that's kind of the standard that people are using. So rather than reinventing the wheel, we're trying to go with what the crowd likes to use. Because the more we fit, again, this is that frictionless idea. We want to try to deliver the software to the users using idioms that they already know how to do. Sometimes they call it idiomatic programming. I don't like that, though. It sounds too close to idiotic.
In many.
So this is a little box diagram of Kubernetes, showing that you have this API node, which is the controller basically, and this can be replicated in the same way that the JMX management node can be replicated conceptually, and it's controlling, in this case, 2 nodes. Now a node is basically a computer, a server of some kind, and inside each node you have one Docker server, and inside the Docker server you have any number of pods that are the unit of work in Kubernetes. So everything happening in Kubernetes is basically scheduling a container to run in a pod. And that's the core of what Kubernetes does. Now there's a lot of extra stuff on top of that, but that's what it boils down to. Another feature that Kubernetes has is this built-in DNS. So this is how Kubernetes is able to manage the Docker networking between all of these containers that are running, which is the built-in DNS will find out what the actual IP is for the real cluster, so that it populates the DNS based on the workloads that are running or not running, and that's how you can achieve the dynamic nature of Kubernetes. The idea with Operator is just to make it real easy to deploy coherence inside of Kubernetes. And as I said, we're already providing EFK. We're using Prometheus and open tracing to scrape the management data from JMX and expose it via Grafana. And the real art of anything that's using a Kubernetes operator, this term operator, applies to Kubernetes, and it means the way to run software inside of Kubernetes intelligently. So you can find operators. I think there's something called operatorhub.io. It's a new effort that started with JBoss and IBM and Red Hat. Not JBoss, Red Hat and IBM. Well, actually, that's the same thing now. Some other partners, I'm not sure. It's called operatorhub.io. That's what it is. And so that's where you can basically get all of the operators, including this Oracle one, when we get it out there, will be in the Operator Hub. And any operator takes a mapping of what the internal software does and finds a way to run it inside of Kubernetes. Now, Coherence has done all of this for a long time. We've had nodes, we've had scale up, scale down, we've had rolling upgrades, all of these things that Kubernetes does, Coherence has been doing for like 12 years now. So the art in producing the operator is just finding a way to map those concepts to what Kubernetes is doing. So we have stateful sets to provide for scaling. We have, we map our availability domains to zones and fault domains. So there's a big persistent volume claims, for example, to support the storage. So basically any concept you can find in Coherence, there's a similar mapping in Kubernetes, and the operator manages that for you. So this is what it looks like to install it. You just, Helm install a couple of charts. Helm is the package manager for Kubernetes. If you've used Linux, you probably have typed apt-get something somewhere along the line. This is like that, but for Kubernetes. You just do Helm install, and there is a chart repository, much like there's a Linux package repository of all of these things. And it's an important distinction. What's the difference between a Helm chart, this is the Helm chart, and an operator? Well, basically, you install an operator with a Helm chart, but it has a lot more smarts baked into it. So that's kind of a Helm chart's really just a very simple thing, but if you are installing something that's an operator, it actually stays in memory as a pod and is able to manage other things in the cluster. So here's what that looks like. Once you deploy Coherence inside of Kubernetes, you have several container pods, and I'll be showing that. And I want to take note of this number. Where's this? 34. Okay. So we have 1, 2, 3, 4 pods running Coherence containers. We have the one pod running the operator, and then these 3 additional pods, one running Elasticsearch and Kibana, one running Prometheus, and one running Grafana. Now, that's a lot of machines that are running to get the job done. So if you're using like Docker for Mac or Docker for Windows, which has a built-in Kubernetes cluster thing, it's really hard to get this much running on your average laptop. You need a really good, powerful desktop to do this locally. But most of the time, you're doing it on a cloud data structure, a cloud deployment anyway, so this is not a problem at all. Okay. Now let's expand that to availability Kubernetes zones. Here we have, the same thing as before, zone 1 and zone 2. And that is how the replication can happen to provide more reliability from data centers. Let's see here. Another point I want to make with this slide is we have this Coherence Docker image, and then we also have this Acme application Docker image. This is called a sidecar Docker image, and this is basically how you get your application, your custom code that's using Coherence, into the cluster. You package the jar file or the config files or whatever you like, and instead of putting it in a WAR, you're simply putting it in a Docker container. So anything that Kubernetes is doing, it has to pull images from a Docker repository of some kind. So instead of publishing WAR files to a Maven repository, you're publishing Docker images to a Docker repository. It's the same idea. And what happens when you start up your application, the operator will, you tell it, this is my sidecar, this is where my application files are, and it simply opens up the Docker image and copies the stuff out so it can be made available on the class path for Coherence. Okay, so persistent volume claim, that's just the way we expose active persistence. And now it's time to get into the demo. So the first thing I'm going to show with the demo is the Oracle Cloud Infrastructure Kubernetes engine. So let's go to my notes here. Okay. Hold on, press the wrong function key. There we are. Okay, so I'm going to log into the Oracle public cloud here. Okay. And just wanted to show you the dashboard here a bit.
Eddie,
Yes. Oh,
you're not showing
thank you.
anything.
I'm going to turn on mirroring. You didn't miss anything. Displays, arrangement.
Oh, by the way,
Mirror.
displays. Oh, okay. Never mind.
Okay, there we go. This, I don't need this anymore. Don't need Slack anymore. What else can I get rid of? That's enough. All right, so let's log in. And if you sign up as an Oracle Cloud Infrastructure customer, you can get access to a couple things, well, lots of things, but only I'm going to show you two things here that are relevant to my presentation. First is the Oracle Container Registry. So this is where you push your Docker containers that your application needs. So you can see I have a few things that are pushed there. First, the coherence itself. Then I have, let me see if I can make this, do it this way and then zoom in. Yeah. So this is the operator, that pod that's running the software that knows how to manage the thing. And here is my sidecar. So I have two different versions of my sidecar that I've deployed. And all of these are namespaced for me. So when I run the Helm chart, I'm going to be able to tell the Helm chart, this is where you put this prefix on there for my stuff. You don't have to do it that way, but me as a developer of the operator, I need to do that. So, because we're all sharing the same cluster, basically. All of the developers on this thing are sharing the same cluster, and the build server is using the same cluster as well. So we have to namespace our Docker builds for this purpose. Okay, and then the other thing I want to show is this is the dashboard for Kubernetes. So you can create Kubernetes cluster, and once you do, you can put it in a compartment. I have dev or stage, for example. These terms are quite common. If you're working in the cloud, you're going to get to know them very well. And my demo is running inside of the dev1 cluster, and this is the cluster ID. So I'm going to jump now to the command line and show you that I am in fact using dev1. So here, zoom out, move this up here, and minimize this, and zoom in. Here we go. So you can see that I'm using dev1, and I want to show that my cluster ID matches. So here we go, get me the clusters. You can see here that we have this C3DGNDMB. Remember, pets, not cattle, not pets. So this is that there. Okay. All right, so that shows, this is how we get from the cluster in the console here out to the command line. Now, the next thing I'll show is when you say get pods. So I'm saying kubectl, K is my alias for kubectl. NS is just, I'm deploying to a namespace. So in Kubernetes, you deploy things into namespaces. And these are my current pods. So that diagram I was showing with all the different pods on it, this is what they are. So my demo is running in one storage node. My demo web app is running in another pod. Then I have the operator running as a pod, and then I have the JAMX server running as a pod. And when you say kubectl get pods, it will tell you, it'll list all the pods that are running in that cluster, and it'll tell you if they're ready or not. So right now they're all ready because I've been running the same demo all week long. Okay, the next thing I want to mention is everything that happens inside the Kubernetes cluster is inside the cluster. It's a world of its own. So to get anything in or out, you have to provide a load balancer or an ingress controller or any number of different services that provide access to what's happening inside the cluster. So for this demo, I'm going to be using a cheap and dirty thing called port forwarding, which is kind of like when you run a Docker container, you can just say map the port inside to the port outside. Same thing, it's just doing it for the entire cluster. That's something you just do for development, though. You can't really rely on port forwarding as a production-ready feature. Because you got to remember, Kubernetes itself is only a version like 1.12 or something. It's still really new. In fact, just this year, they're all happy because they celebrated their 5th anniversary of Kubernetes. So we in Java land are like 5 years. Come on. Try 22, coming up on 25. That's much longer. So anyhow, I'm going to set up these port forwards so my demo can work. So the first one here is this little script, port forward demo. And this lets me access the web app. And then the other port forward I'm going to do is to open up the JMX port so I can show you the visual VM working. Okay. Now we'll go over to the demo web app. Okay, right here. So the demo web app is a simple stock ticker type application. So we have, and this is actually available on GitHub. The demo app is in the Coherence community. Let me show you the link for that. Show all history. If I search for GitHub, there it is. So if you'd like to take a look at the demo app itself, it's got a React-based front end with showing Java 8. All of these things that I mentioned in the talk are leveraged in this demo application. And when you deploy it, this is what it looks like. You have some fake data with 6 different stock ticker symbols. You have a data aggregation graph showing you how long it takes to perform this data aggregation on the server side. And then you have a map of the database, the data distribution. So we have 101,000 positions, and we currently have 1 cluster node. So that's very vulnerable. And I'll show you what I mean by vulnerable. Well, basically, that means if it dies, we lose data. That's no good. So we're going to open up JMX and see what it says about losing data. Another question, have we given a talk here about Visual VM?
I believe we did in the past.
Yeah.
In the past, okay.
When using GraalVM, use the JVM.
Okay. So Visual VM is a really useful open source tool. It was developed inside of Oracle, but it recently was put out to GitHub. And we have a plugin for Coherence that lets you access a lot of the data inside of Visual VM. That's a lot of the data inside of Coherence with Visual VM. So once this fires up, I'll show you that the cluster is in endangered state. There's only 1 node. And then we're going to scale this up, and we'll see that it goes away from endangered state. So you might ask, well, why is he manually scaling it up? Well, that's just because it's a demo. Obviously, in production, you would have the triggering of scaling set up to some kind of metric, and Kubernetes handles all that for you. Because we're implementing this as a stateful set, then it's just the standard way of doing this with Kubernetes. There's nothing new. Again, the idea of frictionless. If you know Kubernetes and you know how to run it, we're not introducing anything new here. This is a Kubernetes native feel to the application. So this is what the plugin looks like. And it gives you lots of nice graphs, memory details, publisher and receiver of packets, and you can look at the load averages on the cluster machine. Now there's just 1 node here, so it's just going to be 1 data series there. Inside Coherence itself, we have a number of services, and the main one that you'll use is the cache service. We're using distributed instead of replicated here, and you can see that it's showing as endangered. So what we're going to do is scale this up so that we are no longer endangered. So we're just going to do kubectl scale. Let me make this bigger. kubectl with my namespace, scale stateful sets, and we're giving the name of the service, which we've deployed with the Helm chart, and we're going to set the replicas to 4. All right, and it will quickly return saying the same thing I did here, scaled, yep, right there. And now if we go down to this browser, you can see very shortly, there you go, it added another node, and it's rebalancing the data. So instead of one node with 100,000 positions, we now have 2 with about 50,000 each. And because it's a distributed cache, it's, again, optimized for better read performance there and decent write performance. Now this should shortly turn green when it gets to adding 3 nodes, because it goes from 1 to 2, and 2 to 3, and then 3 to 4. And we can track that progress here in kubectl. If we say get the pods, you'll see that it comes back with 3 nodes now, 0, 1, and 2, but this one is still initializing. It's got that status of 0 there. Now we got it. Yeah, there's number 3 coming in. And you can see our aggregation process is kind of taking some hits. It costs more to do aggregation, because this is just showing I'm crunching data, I'm crunching data, I'm crunching data. And you want this to be as low as you can, because this is how long it takes to crunch the data. And so when a new node comes online, temporarily, it gets a little longer to do that. Now let's check here. And now we're showing machine safe. So we have a number of different states. There's machine safe, which is the basic level of safety. Then we have node safe, which is even more, and then site safe, which is you only get when you have federation going on. You can lose a whole site and not lose any data. All right. Let's see, we're still at 3. I just want to get it all the way up to 4. Oops. 0, 1, 2, 3. All right, so we're getting the last one in 0 status. Okay, are we there yet? Not there yet. There it is. Okay, we have 25K in each one. The last thing I want to show is how we can deal with the M-beans here. So I know Brendan Burns just said, you should never SSH into the machine and look at log files. Well, sometimes it's useful to do that, particularly if you're going to be doing, if you have JMX turned on, it's very easy to do that. So I'm going to show how we can change the logging in the web app node here. So first, I'm going to show how to get the logs of the web app node. You would just say, there it is, kubectl namespace ns logs -f, which means to follow. I want you to get the logs and just keep tailing them. And this is the demo web app node. So we're going to log in there. And it's going to spit out a bunch of stuff right away, because it gives you all of them from the beginning of when the pod started up. Now, but it goes through pretty quick, and then we're done. Okay, so now all of those other log messages you saw were coming from coherence. I have turned off the logging, so now the only logging we're seeing is the React client, which is hitting the server to get more data. That's this chart being populated here. So if I clear that, you can see it's still pinging to get that data. Let's turn on some more logging. So we're going to use JMX and go to node 29, which I could discover the number that matches the node by going to other places in this UI, but I happen to know that the web app is 29. And the log double is currently -1, which means don't log anything. So let's turn it to log level 5, and what we should start to see is the health check log messages. So a really important concept of Kubernetes is the so-called health check, or liveness probe, or readiness probe. These are 3 names for similar concepts. And when you're deploying an application to Kubernetes, you have to have some way for Kubernetes to learn the state of your application. And because everything is customizable. There's no way for Kubernetes to know this unless you can tell it. And they've chosen to use REST again. So when you deploy your app, you simply say, this is the URL you should call to ask if I'm healthy or not. And you can return 200 if everything's okay. You can return various levels of 500 to mean various kind of problems you're having. So what Coherent's operator does is it provides a health check that joins the cluster and determines its health and then sends that back to Kubernetes. So those are the messages we're seeing here. So these are just member joined and member lost events that are happening. So the last thing I'll show is the ability to sort of, if you're doing this in production, you're trying to get a handle on what's happening, you could actually put a custom string into the log messages right here from the UI. So we'll just say, hello, Sujava, and press enter. And now the next time a log message comes around from the health check thing, you'll see it'll say, hello, Sujava in there. What is it? Oh. Yeah. So I was able to insert a string into the logs as it was running. And that's just kind of a fun thing, but it could be occasionally useful to do that. And turn that off. And set the log level back to -1. So we don't see those bothersome messages anymore. We'll just see the REST messages. And then we'll scale it back down to 1 replica. And we're not going to be losing data, again, because of the health checks. If we didn't have the health checks and you tell it to scale stateful sets, it'll just kill things indiscriminately. And that could cause lost data. So with this approach, it gives you safe scale up and safe scale down. Now we've gone from 4 to 3, and we'll do 3 to 2, and so on. So that is my demo, and I'll go back to the slides and ask if anyone has any questions. Any questions about this? Does this seem like a useful, interesting thing? Okay, good. Any questions from online? More questions from online?
Nope.
Okay. There's a question.
With your question.
Okay.
I believe you set the log.
I believe you set the log to +1 instead of 1.
Oh, +1? Oh boy. Well, that would just mean that we get some, but not much. Yes, I did. You're right. Good catch. All right. And so it's a good point though. This is kind of a silly example. But
Sure.
again.
Yeah.
Let's kill this. And back to here. But there's tons of stuff you can set here. Anything that's customizable. The UID of the cache, the unicast port, and you could really mess things up. So, of course, it's secured as well with JMX. What's another one you could do? Oh, here. So inside the cache, this lets you look at the different services, and here we can see these are the 2 different caches we have in the application, prices and trades. And if we click on this, we just have the 1 node, and here you can set like the high units, the high watermark of the cache, and when you use this plugin, it gives you, shows you the statistics of cache misses, cache hits. It's very, very, very auditable. Total gets, total millis, units, all of this is, of course, well documented in the coherence documentation, but it's very amazing how deep you can dive on this. Any other questions or observations or comments? If you have any JSF stuff, we'll save that for the Q&A part, which is coming up next.
Okay, so should we have a 5 minutes break?
That's a good idea. We'll take a 5-minute break.
Okay.
And then do that. Okay, well, thank you for your attention.
Mata aqui?
Não, deixa eu lá, 5 minutos.
Não, tipo, porque o Q&A pro pessoal não vai fazer sentido, vai.
O cara pode fazer perguntas.
Ele ia ficar muito grande o vídeo.
My name is Diego. I work for Encontro. Nice to meet you.
Não, você
Just
sabe.
want to ask you, you said that you use it.
Ah, depois você edita, então eu não faço nem ideia como editar, pra tirar.
And then you also said that coherence has also an operator. Yes, that's right. So inside the environment, you actually have like two operators with different functions.
Well, it depends on how you want to use it. So if you are already using WebLogic and you're just using coherence, and like it's backend stored, so you can configure coherence inside of WebLogic to be where sessions are stored, for example. Then you would use the WebLogic operator.
Oh, okay.
Coherence operator would be if you're using coherence standalone.
As a standalone. Yeah, I mean, if I have the logic operator, I wouldn't need the coherence operator. If I was, I mean, using this as a cache for my application inside the application. But if I want as a data grid, I mean,